All right, AP Environmental Science. We are going to continue today with Unit 9. This is another one of these, again, kind of big global topics that need to be discussed in Unit 9. Topics 9.3 and 9.4, which is on the greenhouse effect. So you guys have been hearing me, kind of referencing the greenhouse effect and global warming a lot this year. So today we're going to really finalize this topic and just kind of really explore kind of the core problem with global warming. And then we'll kind of talk about some of the effects of that in the next couple of lectures. But let's kind of talk today a little bit about how the planet naturally gets warmed. I mean, it is kind of important that our planet has a moderately warm temperature to it. Life on Earth wouldn't be possible unless there was heat that was trapped on our planet so that could keep organisms alive. But here, this picture I think does a pretty good job showing us of how the planet stays warm. Again, we have all of our energy produced from the sun, and some of that energy is blocked up in the it's blocked up in the stratosphere, and some of it never even reaches the Earth. But a lot of the sun's energy eventually will penetrate through and reach our planet. But when it hits the planet, we've mentioned this before, that some of that energy is re-radiated. I mean, it kind of bounces off the planet, and it could just escape out into space. So again, all that energy is coming in from the sun. Some of the living things on the planet absorb that energy, like plants, and they use it to photosynthesize. But really, whatever doesn't get used pretty much goes back outwards. It just re-radiates out into the atmosphere. Now, we do have greenhouse gases. We have these gases, this thin layer that kind of builds up within the troposphere. This is not in the stratosphere. Stratosphere is like way up here somewhere, okay? So this is all kind of tropospheric level stuff. It's like happening like in the area of the atmosphere where we live. So those gases, and we'll talk about the individual ones in a few minutes, when all that re-radiated energy, kind of bounces off the Earth, some of those gases can trap that energy and bounce it back towards the Earth. So that energy kind of stays in the atmosphere. Some of it escapes, goes into outer space, but some of it gets directed back to the planet. And that energy is basically in the form of heat. So essentially, these greenhouse gases just trap some of the heat from escaping out into into space. They keep it here on the planet. And that's a really important thing, because if you removed these greenhouse gases, all right, then all that heat would escape and the planet would be a lot cooler than what it normally is. Okay. So again, just to summarize this, the sun's solar radiation warms the Earth. Some of this energy is absorbed by living things. We know that. Some of the energy gets reflected and re-radiated back into space. Some of this energy, some of this heat, is absorbed by greenhouse gases and it gets sent back towards the Earth. So again, that's kind of an important thing. The greenhouse effect, people think of it as like a negative. It's not a negative. It's actually a really important thing, because without the greenhouse effect, which is this ability of these gases to trap heat in the atmosphere, then it would be a lot more difficult for living things to survive. Okay, so that's a really important thing, that those greenhouse gases are there. And they've been there for millions and millions of years. All right, one thing to note, again, I don't want to confuse people with this, but the greenhouse gas layer is in the troposphere. The ozone layer is up in the stratosphere. So we are talking about two different things. Don't confuse the ozone layer and its function with the greenhouse gases and their function, because they are different. Okay. All right. Now, the problem with the greenhouse effect is we are doing things anthropogenically to alter the natural state of these greenhouse gases. Normally there's greenhouse gases that are trapping this heat in, okay, but we are putting so many of these gases into the air, through anthropogenic activities, and there's a lot of them we'll talk about today. A lot of them we've already talked about this year. That there's more greenhouse gases than there ever has been before. So the more greenhouse gases you have, the more heat they're going to absorb, the more heat they're going to re-radiate back to the planet, and the warmer the planet's going to become. So I want us to think about this picture and this picture, okay? This is normal, where that amount of greenhouse gases is fairly minor, but again, if we're putting more and more of these gases in the atmosphere, then we're increasing their ability to absorb and to reflect heat back towards the earth. All right, so that's kind of a major problem. So, definition of greenhouse gases: gases in the atmosphere that absorb and emit radiation towards the earth. There are several greenhouse gases, um, but these are two that are not greenhouse gases. I mean, oxygen and nitrogen, they make up about 99% of the atmosphere. They are not greenhouse gases. They are not the culprits. They're not the molecules that are causing the planet to become warmer. It's that other 1%. The other 1% of the gases that make up our atmosphere are pretty much greenhouse gases. But again, there are several. So we'll talk about those on the next slide, or the next couple slides. But again, without these greenhouse gases, I do want us to understand that, I mean, they are important, but we don't want too much. It's kind of like, anything in moderation, right? I mean, you don't want too much of a good thing, because too much is too much. If we have too many greenhouse gases, then that's going to cause the planet to become warmer. If we don't have any greenhouse gases at all, the planet's going to be like super cold. All right, so we just have to make sure that we're not putting too many of these substances up into the atmosphere. So let's kind of go through just the list here of kind of the major greenhouse gases. Number one is water vapor. All right, water vapor is a greenhouse gas. In fact, it's the most common greenhouse gas. But water vapor doesn't really stay in the atmosphere for very long. I mean, we know like water evaporates, goes up into the air, but then it comes right back down to the earth again in the form of precipitation. So even though water vapor is a greenhouse gas, it's not really like a major problem, because once it goes up, it comes right back down again. So it's not that big of an issue. Now, these other ones are carbon dioxide. We've talked about it a lot this year. Methane, and make sure we know the formula for methane. Nitrous oxide, N2O. We'll talk about that one in a minute. Ozone, tropospheric ozone. Now, this is the stuff that's in the troposphere. The stratospheric stuff, that's different. Okay, that's not what we're talking about here. These four, one thing I want you to know about them is that they can go into the atmosphere naturally. Like when a volcano erupts, it spews a lot of carbon dioxide into the atmosphere. Okay, when animals breathe, we put carbon dioxide into the atmosphere. But there's a lot of anthropogenic ways as well. So all four of these, there are natural and there are anthropogenic reasons for why those things go into the atmosphere. We're going to be kind of focusing on those anthropogenic things. And then finally, CFCs, HCFCs, even HFCs, all those things. Those are strictly anthropogenic, though. All right, we talked about those in yesterday's lecture. These are things that are only put in the atmosphere by humans. They are man-made chemicals. They are not natural. Okay, so that's one thing that we can definitely control. Term here is called the global warming effect, GWP. It says here it's an estimate on how much a molecule of any compound can contribute to global warming over a period of 100 years compared to a molecule of CO2. Like we know CO2, causes global warming. Okay. In fact, CO2 is the molecule that we use as our standard. So what we do is we pretty much compare everything to carbon dioxide. So we assign carbon dioxide a value of 1. That's its value. That's its global warming potential value. Methane has a GWP of 20. So what that means is that one molecule of methane is 20 times more problematic, when it comes to global warming than a molecule of carbon dioxide. Okay. Nitrous oxide, N2O, has a GWP of 300. Ozone up to 1,000. CFCs up to 10,000. HFCs or HCFCs up to 12,000. So, you can see that, as we go down this list, the global warming potential gets much higher. So you can probably see why, for example, in the Montreal Protocol, we wanted to ban CFCs. One problem is because they destroy ozone, but they also are greenhouse gases. So what did we do? We replace them with HFCs. HFCs don't destroy ozone, but they're an even bigger greenhouse gas than CFCs were. So again, we tried to solve one problem and we kind of created another one. But be familiar. You don't really have to memorize these numbers, but I think it's really important that we know that carbon dioxide is the standard, and then sort of the order at which these go as far as how they increase their GWPs. HFCs and CFCs are terrible. They're like the worst things, all right, for the environment when it comes to global warming potential, as far as an individual molecule goes. But if we look at, as far as like what's really the worst thing, it's carbon dioxide. Carbon dioxide is the biggest, or I should say, it's the most abundant greenhouse gas of them all. It says here carbon dioxide has the greatest overall impact on the greenhouse effect due to its high concentration. You just look at this pie chart here, okay? Carbon dioxide is actually in 2 slices of the pie. 65% of all greenhouse gas emissions are because of carbon dioxide through fossil fuels. That's basically it. 11% is carbon dioxide through forestry, like removing trees, which we've talked about before. So basically, almost 3/4 of all carbon, or of all greenhouse gas emissions, are just carbon dioxide. Now, yeah, carbon dioxide does have a low GWP, but because there's so much of it, it's a major issue, bigger than the other ones. Those fluorine gases, which we said are really bad. They have a really high GWP. They don't really make up that much of our greenhouse gas emissions, especially now since we have the Montreal Protocol. But CO2 is the big one. All right, so let's look at some of the sources of some of these greenhouse gases. All right, let's start here with just carbon dioxide. Like, how does all this carbon dioxide get into the air? According to this pie chart. Now, this pie chart here is basically referencing this chunk, this 65%, fossil fuels, industrial processes. So, as far as carbon dioxide goes, transportation is a huge emitter, right? Cars, automobiles, tons of CO2 emissions. The other one is the production of electricity, right? Burning coal. Right? We've talked about this all year long, okay? On the AP test, they will ask you, okay, whether it's multiple choice or it's an open-ended question, whatever it is, they're gonna expect you to know how carbon dioxide gets into the air. How, going back to this pie chart, this 65% that makes up all greenhouse gases, like, where does it come from? It's coming from our cars and it's coming from burning coal. Those are the 2 major things. Okay. Now, I don't want to neglect how big of a problem deforestation is when it comes to carbon dioxide. Again, when we remove trees, removing a tree doesn't necessarily, well, I mean, it does put carbon dioxide into the air, but one of the biggest problems with it is you're removing the tree's ability to remove carbon dioxide from the atmosphere. That's a huge problem with deforestation. Is when we remove the tree, that actually could release CO2 from the soil, which is bad. If we burn the tree, that could release carbon dioxide into the air. The machinery that we use to remove the trees puts CO2 into the air. But I think one of the biggest things is we're removing an organism that has the ability to take CO2 out of the atmosphere. That's a big problem. All right, so don't forget, that deforestation when it comes to carbon dioxide and greenhouse gases is very problematic. Methane gas. So methane is another greenhouse gas. How does it get into the atmosphere? Let's look at these three chunks right here of this pie chart. All right, let's just start with these two that are 28% each. So that if you add that up, that's more than half the methane that goes up into the air goes from these two things. One of them is something called enteric fermentation. All right, enteric fermentation is basically methane that's produced from the digestive system of animals. Okay, termites are big um, methane gas producers. In fact, they produce a lot of methane gas, probably more so than any other organisms on the planet. Uh, Now, this picture here, which is kind of cartoonish and it's kind of funny to look at, but um, cows, or just animals that we raise for food, right? Those animals do produce methane. That's enteric fermentation. That's digestive methane gas that's being produced. We've talked about agriculture and the food crisis, right? We need to have more food to feed 7.5 billion people. Well, we got more cows on this planet than we ever have before, and those cows, every one of them farts and they produce methane. So we're increasing our greenhouse gas emissions partially because of our population size demanding more food. All right, so there's methane gas, agriculture, enteric fermentation. Um, Petroleum, natural gas. Every time you turn on your stove, you're burning natural gas. So again, that's another source of methane. And then there's what we talked about in the last unit. This is landfills. Right? We throw all of our garbage into a landfill, we cover it up, and we create that anaerobic environment, and that generates methane. All those bacteria produce methane gas. So 17% of all methane that's produced comes from landfills. So again, you're going to be expected to know this for the AP test. Know how methane gas gets into the atmosphere. Digestive systems of animals, it does go up there that way. Burning natural gas, and also landfills, three major sources of methane. Nitrous oxide. Nitrous oxide, N2O, I mean, really, when it gets down to it, there's really one major source. 78% of all N2O gets into the atmosphere um, basically through bacteria that live in the soil that convert nitrogen into N2O. Now, they do that naturally as part of the nitrogen cycle. There's certain species of bacteria that produce N2O. But when we add a bunch of nitrogen-based fertilizers to our crops, which we do everywhere, right? We're increasing that. We're kind of forcing those bacteria to produce more nitrous oxide, N2O, than ever. So, I mean, that level of that particular greenhouse gas is mainly going up due to the farming industry and again the need for food, the need to grow crops. We need a bunch of fertilizers, and that's going to increase N2O. Okay. Fluorinated gas. Again, we talked about this one in yesterday's lecture. There's really only one reason why we have all these compounds, CFCs and HFCs, and that's mainly through just the release of these ozone depleting substances, right? CFCs that were used back in the 1970s, HFCs and HCFCs have replaced those, but all of these are greenhouse gases. So, these were ozone depleters, CFCs. These were the substitutes. All right, these are even worse greenhouse gases than CFCs were. All right, so again, that was mentioned in yesterday's lecture. You might want to go back if you didn't understand that, but this is the major source of those things. Tropospheric ozone, another greenhouse gas. We learned in Unit 7 that tropospheric ozone naturally builds up during the day. It's a natural process, but it normally breaks down at night, right? But there are anthropogenic things that we do, right? Like releasing FOX chemicals into the atmosphere that inhibits the breakdown of that tropospheric ozone. I'm not going to go back into that. You can go back to Unit 7 and review it. Highly suggest you do that for the AP exam. But understand that the buildup of tropospheric ozone, that is a greenhouse gas, and that can lead to global warming. So just to kind of summarize, today what we've kind of talked about, you know, the, the proof is in the data. I just look at these charts. I mean, these are going back to the early 1980s, maybe the mid 1970s, and you can just look at each one. I mean, carbon dioxide levels. I mean, just look at what's happening to them. I mean, you can't really dispute the statistics. Nitrous oxide. Just look at the trend. I mean, look what's happening to the levels of nitrous oxide. Methane. I mean, we see the same thing. Now even when we look down here, CFCs, right? Remember CFCs? These are those refrigerants that were used back in the 60s and 70s. You'll notice that they were increasing, obviously. But remember, the Montreal Protocol kind of banned those in the late 1980s. You can see that those have started to go down. But it's taken a while to even get to that point. But the replacements were HFCs and HCFCs. So those have gone up. Those are greenhouse gases. These two at the bottom, in fact, all four of these are greenhouse gases, right? But at least the top two have started to go down because we banned them, but we've replaced them with these two, so those are going up. So again, we haven't really solved the issue of greenhouse gas emissions when it comes to these chlorine-based compounds. But we've got to do something, right? Now, today is April 23rd, 2021, and it is Earth Day today. So I thought I'd just share this with you because I think it's really relevant to what we're kind of talking about. Yesterday, President Biden, vowed to cut greenhouse gas emissions in our country by 50%, which, I know it's just words, and actions speak louder than words. But I think this is a big statement, and I think it's also something that the rest of the world, hopefully, is on board with. I know he has a lot of countries that he's working with, and that we're working with to try to reduce global greenhouse gas emissions. But I guess we can start in our country. I mean, let's try to control what we can control. We can't really control what's going on in France or Japan or in South America somewhere, whatever. But in the United States, the fact that we have a president or we have a body of government, that's willing to look at this issue and try to do something about it, I think is a really big deal. So maybe this is just a start. And maybe we'll get to this point in the next 15, 20 years. Maybe we won't. But at least it's something I think worth looking into and looking at possibly reaching that goal, hopefully. So I thought I'd share that with you because it was again this was on April 22nd, so this was yesterday that he made this statement. All right, guys, that's it for me for today. I will see you soon.